recorded. And that way I will post the link to this recording in case anybody has any technical difficulties going in or out, or just for kicks wants to rewatch what we're talking about today. So hopefully you had the time and opportunity to do the prep work, to really watch those couple of videos. And our topic today is the developing brain, the infant, child, and adolescent brain. And so we are going to start off by, not shockingly, playing a Kahoot. All right, so let me share my screen and we will play. 698-8843. All right, about 10 more seconds. All right, let's get started. Which cranial nerve helps regulate body temperature, heart rate, and digestion? You guys are fast. So fast. Okay, that is the vagus nerve. Remember, we talked about that if sometimes people are getting blood drawn or getting a shot or something that's making them really anxious, they'll hold their breath, and that creates pressure on that vagus nerve in the gut and ends up causing them to maybe faint. Number 2, which area of the brain is said to be linked to visual processing, color identification, and reading skills? Super speedy, and most of y'all got this. So that is indeed the occipital lobe. What part of the brain is associated with control of executive function? There we go. It is the prefrontal cortex. That frontal lobe, the very front part of your brain, is where you could think of it as kind of the administrator that sits behind a big desk in the front office. So that's where your higher order thinking, especially making decisions about big things like time management, social cues, and impulse control, things like that. That's your frontal lobe there in the prefrontal cortex. Multiple answers may be possible. Which 2 neurotransmitters are the only ones found in the peripheral nervous system? Yeah, I don't know why that is not showing too, though. So what are our correct answers? We have norepinephrine, and what's the other one?
Acetylcholine.
Yes. Good. So, all right, I'm gonna make a note to fix that on the Kahoot. Sorry about that. All right. And this is the last one. What part of the nervous system includes nerves that connect to the skin, sensory organs, and skeletal muscles? So that is the somatic nervous system. Here is our podium.
Dr. Lancaster,
Yes.
I have a question about the one with the neurotransmitters found within the peripheral nervous system.
Yes.
I remember during the presentations, they talked about most of serotonin being found in like your small intestine or in your intestines in your gut. Is that not true?
That's not really what we think of as the peripheral nervous system.
Okay.
So yes, it is mostly in the digestive system. Yes. As
Okay.
well as it's in the blood, acts specifically in platelets, and then throughout the central nervous system. So
Okay.
peripheral nervous system, meaning like peripheral nerves. That's what we're talking about there. So that's a good question.
Okay.
All right.
Thank you.
X out of that so we can calm that music right down. All right. So we have several learning goals for today. I'm pulling up the PowerPoint here. Second, there it is. Okay. So today we're going to talk about the processes of apoptosis and synaptic pruning and how those processes impact the brain. Of course, we're going to talk about the development from early on forward in early development in childhood, really, and adolescence, and then talk about those stages of embryonic development and how the nervous system is involved there, and then major changes that go on in the brain and functional changes associated with that at age 1, 2, and 3. And this is corresponding to the information in the chapters that you read. So there we go. And okay. So we're going to start off by doing a little check-in. I know it's afternoon and I know it's towards the end of the week, so I want to check your battery. If you will, put in the chat, and if you're grouped up with somebody, you can put more than one number. Just take a consensus of your group and put more than one number. But if put a 1, if you are feeling great, you're a-okay. 2 is just slightly under that. Feeling good. 3 is feeling okay. 4 is maybe not. 5 is struggling, and 6 is if you are out of gas. You are really on the struggle bus. Yeah, you guys have had a lot, 5.5, have had a lot going on this week. So hopefully this will be information that will be of interest to you, because it is going to come back to relate to things you do all the time in clinical practice. Even if you think you will never want to work with children or be in pediatrics, people have children, the clients you work with, or grandchildren, and so that will be relevant. And also you may end up in pediatrics. You really never know. So let's do a tiny bit of review about the major areas of the brain. The cerebrum is the largest area, And that does a lot of the higher processes. A lot of the lobes that we talked about before are in the cerebrum. Then we have the cerebellum, a little bit smaller area, and that's the one that I want you, when you hear that, you think coordination, and you think if there is a problem going on in that cerebellum, the person's going to appear to be intoxicated. So they'll be off balance and maybe slurring their words and having a hard time walking a straight line. Then we have the brainstem, and that is what connects to the spinal cord, and it does those essential life functions. So when you see on TV or hear somebody talking about someone being brain dead, that means that they don't have any synaptic activity in their brainstem. So any basic life functions like breathing that are going on are being artificially controlled, so by machines and medicine. Now, just as a point of interest, the cerebral cortex, so that cerebrum it's less than 1/4 of an inch deep. So it's not very deep, but there's a whole lot there. Things are really very packed in that area. When you see a drawing or even a photo of the surface of the brain, you will see it looks kind of like noodles to me. You will see that there are ridges and grooves. They're kind of upsides and then downsides where it's convex and concave. Those ridges, the upswing areas, those are called gyri, Gyri. And the downside, the grooves, are the sulci. So you may hear or see descriptions talking about different areas of the brain and that are gyri and sulci there. That's just the up and down part of the brain. There are 3 membranes that surround the brain. So it's like a 3-layer covering of the brain and also the spinal cord. So the whole central nervous system, all of these together are called the meninges. But the 3 layers each have a name, and you can see that here on this slide. The outermost layer, the one just underneath the skull bone, the one that's closest to the skin and the air, is the dura mater. Then in the middle is the arachnoid layer, and then closest to the brain, the innermost, is the pia mater. So dura mater, arachnoid, pia mater, the DAP. And notice here on the slide that it talks about how the arachnoid mater contains the blood vessels. And so that's really because it protects them, the vessels there. Now, you're going to hear these terms when we talk about other things, both in the remainder of this course and in neuro aspects, things like a subarachnoid hemorrhage. And so that means there's bleeding that's just underneath that arachnoid layer, but not into the pia mater. So it's in between. If you're looking at this slide, it's in between the green and the bottom sort of yellowish greenish layer. And that would be, problematic because it's putting pressure on the brain down below. So it can cause problems like seizures and other things. And so these are all part of the protection of the brain. It's fairly sturdy. I mean, it is encased in a bone, and then it has those multiple layers, but at the same time, it is at risk for injury and certainly even illness. When things do cross the blood-brain barrier, it can result in problems. And one that relates to one of the terms we just talked about is meningitis. Meningitis actually means inflammation of the meninges. So any or all of these 3 layers will be inflamed. And again, that puts pressure down below on the brain, and the brain has nowhere to expand. If your toe is swollen, it can just expand out into space. You can end up with a giant toe, and it does hurt, but it's not really that bad because it has space to expand. That's not the case with your brain. It's just, it only has the area inside your skull. And so if you have meningitis and those tissues are inflamed, that is taking up some of the real estate that your brain needs, and that's why it causes problems. Let's look at embryonic development. Now, this is something you saw in the reading and the video touched on. We're talking about when early on in fertilization. So when the egg and the sperm become an embryo, and early on, you like in the first weeks of conception, that you will see the stages of development that we're seeing then are formation and induction. And during that time, if you look at this picture, you can kind of see there parts of the central nervous system are already starting to form, very rudimentarily, very basically. And so those layers are the ectoderm, that's the outside, the mesoderm middle, and endoderm is the innermost. You see ecto outer, meso middle, endo inner, of the nervous system there, or even just of the embryo. And so then you get to proliferation, moving towards being considered a living, breathing species, moving, towards that. And then migration, that's what is happening in this central nervous system. When you see the little strip that's down the middle of that, in that picture, that is the neural plate, and it starts thickening as more and more cells divide and get added to it. This whole structure that you can see here that kind of looks like a caterpillar, sort of, that's called the neural tube. And that's the very earliest formation of the central nervous system in the embryo. So if we break it down into different parts of pregnancy, the first few months, the first trimester, really thought of as the first 12 weeks, really, roughly. That's when that neural tube and the neural plate are forming very, very early on. Cells are just pretty rapidly dividing and building up so that something more productive can come of it in the second trimester. Now, early in the second trimester, the gyri and the sulci, so that kind of noodle, the up and down of that outer looking noodle structure on the brain, those actually begin to appear in that second trimester. And by the end of that trimester, that process, the outer surface of the brain, is pretty complete in its composition. What also happens or begins to happen in that second trimester, so kind of the middle of the pregnancy, is myelination. And remember that myelin is the protective covering of those nerves. And that process of myelination, or the building of that myelin, continues through adolescence. So it starts even before the embryo becomes a fetus and then is born, but it continues until 15, 16, 17, 18 years old. Now, towards the end of pregnancy, you can see in this slide that the structures, the lobes, the areas and connections of the brain are forming much more. So it's a very transitional period, because the brain or even the whole central nervous system becomes set up for the great division and expansion of those cells even after birth. All right, now when we look at this cute little girl, and we can talk about that first year of life. And as the grandmother of a little girl who is 6 weeks old now, this is something I think about, and I'm really getting to see this really close up, because I see her very often and I see new skills almost every time I see her. Sometimes she's tracking objects better. She's starting to reach out towards objects that she wants, like a ball or her dog or her parents or the window. She likes looking at light, loves watching the fan. We jokingly say the fan is her best friend. But even starting to try to figure out how this outside world works. So in this first year of life, so much is happening in the central nervous system and really specifically the brain. The cerebellum triples in size from birth to the end of the first year. So by the time they have their first birthday, they've gotten 3 times the size of that cerebellum. The visual cortex is growing a lot, and that's what adds to this ability to focus on items that are further away and track things and understand color in a different way and 3-dimensional type things. The hippocampus, which remember goes to memory, it is growing so much in that first year. They're building these memories in this early stage. And the language circuits that go on in that frontal lobe and even the temporal lobe, those are developed more and more. So we see the language centers, the memory, the visual cortex, even the motor potential in that cerebellum really improving in that first year of life. However, the most dramatic changes involve the brain's language areas. We say that that first year of life, what we're looking at there really is the vocabulary explosion. And there's a major increase in myelin, the coding, which means those connections, the synaptic impulses happen faster. So that causes higher order cognitive abilities, like becoming aware of relationships, like who's your mommy, who's your daddy, who's, even awareness of yourself. This is my hand and somebody else has a hand, but that's their hand. Lots and lots of stuff happening in the first and into the second year of life. Now, when somebody is born, they have lots and lots of synapses. We talked about that really already in the earlier session. And so that synaptic density, the massive amount of synapses, really peaks towards the end of that first year. And about that time, young children start having an understanding of cause and effect. One way you can note this is that a lot of times when babies are about a year old and they're usually sitting in a high chair when it's feeding time, and many times you will notice that they will take something like a piece of food or their spoon or their cup, and they will hold it out to the side and then drop it. And you can even sometimes see the wheels turning almost in their head. You can see that look on their face. They're like, let me see what happens when I do this. And they're really trying to figure that out. They're trying to figure out that they can cause something else to happen. So they're not only causing that thing to fall to the ground, probably make a noise, but then usually somebody in that environment will pick it up and give it back to them. So even more of a cause and effect there. And so they're learning in an active way, not just in the passive way of observing things, that they are earlier in that first year of life. Whoops. I missed something. 1 second. All right, so I do have a slide in there that I want you guys to start thinking about an early memory that you have. So let me stop sharing screen just for a minute. And what I would like to do, I'm going to put you guys in breakout rooms, and I'm going to give you 5 or 6 minutes to think about, let's see, I'm trying to figure out how to do this with some of y'all together. I want y'all to share your earliest memory, as far back as you can remember, if you feel comfortable in doing so. If you don't feel comfortable, and that you can just pass. So let's see. We're gonna have, no, that's not gonna work. Let's do, let me assign you automatically first, and then I'll kind of reconfigure it according to who is in there together. So let me do this. Hold on 1 second. Let's do. Okay, so if you are in the room with another person in this class, you don't have to go in the breakout room. You can just do it with whoever you're with. And if you go into a room and you're in there by yourself, I will then shift you to another room.
Dr. Lancaster, I'm not sure what happened with mine.
Let me see here. Okay, can you, you should have gotten a notice on the screen that said join.
I clicked it and then nothing happened.
Okay, let me find where you are, Caitlin. Let's see. Okay, wait a minute. Now I see you. Okay, hold on 1 second. Whoops. Okay, that should do it. Rachel, are you still waiting? Let me find your name on the list. Okay, let's put you in room 8. You see that? You see it? Okay. Everybody else, are y'all with somebody? Yes. Okay. All right. Well, I'll give you 5 minutes, or let's say 6.
Dr. Lancaster,
Yes.
can you put me in another room? My microphone wouldn't work and it kicked me out. I was in 10 before.
Okay, let me see here. Okay, so then I think that's going to leave Hayes without a room. Let me move. Let me see. Okay, I'm going to move you, I think, to room 6.
Okay.
And I will move Hayes in there too.
Okay.
Okay, let's try that.
Okay, thank you. Did you send a notification?
Yes, it should have popped up on your screen. Let me see if I see that you. Why am I not seeing that? Very strange. You have to be, oh wait, hold on. No. Oh, okay, hold on. All right, now I'm sending you room 3.
Okay, it came up
Okay.
this time.
Okay, good. Let's go with that. All right, we got people coming back. Whoops. Okay, so what I would like for you to do now is to put in the chat how old you were when you had that very first memory. Just put a number. So you're going to put like 5 or 10 or 15 or whatever number.
What? Oh, sorry.
2.5 or 3, that's early. Interesting. All of that's on the younger side of what I typically hear people say. Often people will say around kindergarten age or maybe just a little bit before. So probably 5 is probably pretty average there. You guys have some earlier, some of y'all, some earlier times that you're remembering things. So that's really interesting. So again, that in this first few years of life, we are seeing that hippocampus and really the limbic system really refine those synaptic connections through the experiences and observations that the young children are going through. And in fact, one of the most evidence-based areas of OT practice or any type of rehab, I guess, is early intervention. So that's from birth to 3 years old. We see the most dramatic and most permanent positive changes in people, little kids, when they receive OT services. And it's because the brain's so rapidly growing in that time anyway, that they're just very primed for rehab and excellent progress. I say rehab, but really we call that habilitation instead of rehabilitation because they're not relearning something. They're learning it for the very first time. So what happens in those early years, the first 3 years, is that a child's brain has up to twice as many synapses as it will have in adulthood. And so as you can see on this slide, what starts to happen is initially in that first couple of years, we see blooming or rapid dividing. Our brains keep getting more and more synaptic connections at the time. And of course, the myelin is growing to increase the efficiency of that transmission between synapses. Then following that, after those first 3 years, we get into what's called synaptic pruning. And that we've talked about that concept before. That also can be called apoptosis, when just the used or important connections are really kept in this to the same degree that they are originally. So some of that's kind of related to the use it or lose it philosophy, but more so it's just that there's a bunch that we don't need. They're extras, they're spares, and that stuff is cleaned out after the first couple of years of life and on into adolescence. So we call this early stage, the first few years of life, when the blooming and then when pruning begins. Oops, there we go. Why do you guys think that the brain would make so many extra spare connections? That it would be kind of like if your whole trunk and maybe even the back seat of your car was filled with spare tires. Why do our bodies do that? Why does the brain create that only to discard the extras? And the answer really lies in the connection or the interplay between genetics and environmental factors in brain development. So again, our experiences not only determine what information enters the brain, but also our experiences also influence how our brains process information. So experience is key. And, you know, it's important to have young children out and experiencing things and learning and observing and actively engaging. And you can see this little boy who is a now 4 years old, a little boy I know, he's actually has a little bit of drool coming from his mouth because he's so intent on this light bulb that he can't even really pay attention to swallow and control his oral secretions. And that's just kind of how those young children go through life. They're just, everything is new and fascinating, and they're just drinking it all in. So really the important point here is that genes provide a blueprint for the brain, but the child's environment and experiences really carry out the construction. So if we're looking for a metaphor here, we have our blueprint, but what actually gets built and maintained in the brain comes from experiences and environment rather than genetics. So we just said that those early stages of fetal development, the nervous system in fetal development, so that induction, proliferation, migration, all of those things, they occurred in that early fetal stages. But the next phases of brain development, so towards the end of, once they get to the end of the gestation period, once they're actually born, even from day one, their environment and their experiences are impacting brain development. And in fact, the older a young child gets, the more that brain development does depend on things that happen externally or outside of the body. So after birth, things that babies do when they're in a good environment, like watching their mobile spin. I just said my granddaughter is BFFs with the fan. She loves to watch it spin. Listening to a voice. She will track my daughter if she's talking across the room. My granddaughter will about dislocate her head off her shoulders, whipping her head around to see where her mom is according to where the voice is coming from. And so all of those things, that external stimuli and proper nutrition, really influence the connections that are formed and maintained in the brain, the neural connections. So very important. Now, you guys know they're monthly milestones, developmental milestones for an infant and on up to, several years of age. In those first 3 years, the milestones are kind of the checkpoints, you could think of it as, are composed of motor skills, so movement, sensory development, and that I'm not talking about sensory processing necessarily. I'm talking about vision and hearing, things like that, taste, smell, things like that. And language is big, and those things are all part of the developmental milestones, language development. And also we look at reflexes that babies have at birth or they develop it shortly thereafter, and how those reflexes integrate or become overridden by voluntary movement or choices. So one example of that is, and you will learn in the pediatrics course, you actually have a class session that I teach about primitive reflex integration. And I'll reference back to this lecture when that happens. But an example of that is early on in a child's life, they have a response, a reflex that happens whenever they turn their head towards one side or the other. The arm on the side to which they're turning will extend. and the arm on the opposite side will bend up. So it looks like they're shooting a bow and arrow. And then if they turn their head the other way, their arms do the other thing. And this is just something that happens before that synaptic pruning is completed. It's a way that they are just starting to interact with their environment physically. And a few months down the road, their system does that synaptic pruning enough to where they can override that by choice. So they can still choose to do those movements if they want. But you can probably think really quickly about one ADL, one occupation that they need to be able to do that they can't do if they never get out of this reflexive pattern. And that's feeding themselves. So bringing a cup to their mouth or a piece of food or a utensil, if they never integrated that reflex from the time they were first born, they couldn't get their hand to their mouth. So that's one of those primitive reflexes you'll learn more about in a few months. But back to the developmental milestones, many of those milestones are really important indicators about brain development. And that's really why we look out for them. It's not, we don't have that list of milestones to make new parents worry or to have something to do at the pediatrician checkups. We have those as checkpoints. So in other words, looking to see if a baby, an infant, a child is on track. And that tells us, or indicates at least, that their brain development is on track. The brain, in other words, is developing as it should be, or not, if they are not meeting those milestones. So one example of a milestone is around 6 to 7 years of life, the child should be sitting up unsupported. And so if they are not, if they're still having to prop themselves, or if they can't even do that, if they can't maintain sitting, even if they are propping with their hands, then further testing, further investigation has to be done. Every once in a while, the child's just a little bit behind the curve. Certainly if they were premature, that might be the case. Sometimes if they just haven't had the opportunity to practice a lot, they are a little bit behind in their milestones. And Dr. Zachary's area of research for her PhD was the effect of babies that are in what she calls containers a lot. So in other words, baby equipment. So walkers, swings, the little Johnny jumpers, bouncy seats, car seats. When very young children spend a significant amount of time in this type of equipment, that even bumbo seats and things like that, it appears that they are sitting up and doing, different movements, but actually they're being assisted so much by the equipment that they actually don't get a chance to practice that enough on their own. And you'll see that when that happens, we see physical development problems in those children. They may be slower to roll, which typically happens between 3 and 4 months of age. They are typically slower to sit up on their own. They may even skip the crawling stage altogether. They may be later to begin walking, which should happen about a year of age. They may even have a misshapen skull from spending too much time laying on their back or on the side and not having the proper time on their belly and being held and in different positions. So all this to say, again, that environment is very, very important to central nervous system development and just overall development in a baby. There's an organization in Memphis called the Urban Child Institute. It actually is not far from our campus. And this institute is a leader in providing really important information about brain development and the things that influence it. So it relates to that social determinants of health. And do children have exposure to things as they should at a very young age? And whether they do or don't, how does that affect them later in life? So lots of good research coming out of that institute that is right here in our city of Memphis. All right, I have a little video for you guys to watch that is about reflexes.
Babies are born with a set of reflexes critical for survival in the outside world. Some of these reflexes are so obvious you might not think to look for them, such as the breathing reflex or the eye blink reflex. Rooting is one of the most critical reflexes. By touching 4-week-old Lily's cheek, she'll turn her head and open her mouth in preparation for nursing. Once the baby is in contact with a breast, a bottle, or even a finger, the sucking reflex takes over. Involuntary at first, the neonate will gradually gain control over sucking during the first year. Placing liquid in the mouth will induce the swallowing reflex.
In the first few weeks of life, it takes all the baby's concentration just to control these various uncoordinated reflexes. At this age, feeding Julia can take over an hour. After about 6 weeks, though, Julia will be a pro. There are other reflexes babies are born with that we don't completely understand. In the first 2 months, babies exhibit the stepping reflex. This is probably a precursor to walking. Watch Lily's toes fan out and curl. This is the Babinski reflex, which occurs when the bottom of a baby's foot is stroked. When pressure is placed on the baby's hand, you can see the grasping reflex at work. Lily's grasp is strong enough to support almost her entire body weight, for a few seconds at least. When startled or dropped, a baby may respond with the Moro reflex. The arms fling outward and inward as if the baby were broken for support. 2-month-old Julia doesn't even need to be awake to demonstrate this reflex.
Researchers suggest that this set of reflexes were critical during an earlier stage of human evolution, perhaps dating from a time when babies had to cling to their mothers. These reflexes will disappear completely after a few months.
All right, so just a little precursor to what you're going to learn about infant reflexes and developmental milestones in the pediatrics course. All right, so we are at 2:54. Let's take a break to the top of the hour in case you guys need a bio break or get something to drink or just stretch for a minute. So you're welcome to turn your camera off, mute yourself, and we'll come back at 3 o'clock.
Good afternoon, Dr. Lancaster.
Hey, Hunter, how's it going?
I'm doing swell.
Good.
Did you already go over the pre-class video answers,
No.
or was that just more for us to do on our own?
Yeah, it's just more, it really is kind of guiding people as to what to watch for when you watch those videos.
Okay. Okay.
From the University of Chicago, this is Big Brains with Paul M. Rand. Conversations with pioneering thinkers that will change the way you see the world.
Dr. Lancaster.
Yes.
All right. Same question applies to you now. What's the earliest memory that you have?
Okay. Mine is, and I was 5 and I was learning to ride a bike, like a two-wheel bike, without training wheels in my front yard. And we lived actually in Minnesota at the time. So,
Minnesota. Okay.
yeah, we didn't live there not long enough for me to develop an accent from there, but just a couple of years. So yeah, a lot of we moved every year and a half to 2 years when I was growing up because my dad worked for a big company and got transferred that often. And so I can always, if I picture myself in a certain house, I know how old I was when I lived in that house. So that's kind of how I mark time in my own hippocampus there.
I see what you did there.
Yeah, I knew you would. All right, so I have on the screen, this is a little Quinn update. So she now is 6 weeks old and she weighs 12 pounds and she has just started laughing at silly things. So this was her in the bath last night and we were making silly faces at her and she will almost gut laugh. It's super cute. So just one of the many fun and informative developmental milestones that we have to check on, are babies on track for development? Something that's really important. And so we tend to, in our field, we tend to look at physical. That's always the most obvious part of in development. And not only development, but even just the reflex integration. So reflexes really are uncontrolled physiological reactions to specific stimuli. So like the one I was talking about earlier, which is, you don't have to know this now, but it's called the asymmetric tonic neck reflex, or ATNR. And that's the bow hunter reflex. So when the baby turns their head, their arm extends on one side and flexes on the other side of the elbow. And so that's another way for us to have those checkpoints. We also look at social emotional development, how engaged is the baby with people and the environment around them. Do they seem to have an attachment to certain people? Do they, usually about 9 months of age, they'll be really attached to the parents or sometimes even just one specific parent. And they don't really like unfamiliar people. But that's one of the phases that they go through. Now, we also need to consider, because this is also in the scope of practice for OT, it relates to occupations, but language development. This is something that's kind of led up by the speech therapists on the child's team, but it's something that is important, and we recognize it as such because we know that intake of language, and even when babies start babbling and how they get those responses when they start, say their first word pretty close to a year old, and then, get more and more words. And typically young children are expected, just a rough rule of thumb is they should be saying words or phrases that are about the same length as their age. So a 1-year-old you often just says one word at a time, like mine or ball or dog or cookie. When they get closer to 2, they need to, at minimum, string 2 words together, like want more or black dog or that's mine, something. It doesn't have to be a complete sentence, but 2 words together. And then at 3, they should be putting at least 3 words together and so on. Now we're going to do something a little bit unusual, and I hope you guys can hang with me, even though it is mid-afternoon. I have about a 20-minute podcast that I want you guys to listen to. And so let's just take some time right now, and you can turn your camera off and listen to this. I'm going to just play this audio cast and just kind of jot down some thoughts that come to mind as you listen to this. On your guide for today, it says how talk affects babies' brains. So that's what you're really listening for here.
Every parent knows that talking to their kids is important, but University of Chicago professor Dana Susskind found something incredibly intriguing through her work as a leading cochlear implant surgeon. How much parents talk to their kids and how much those kids hear has a profound impact on their intellectual development. Dana was so intrigued by the findings that she founded the 30 Million Words Initiative and published a best-selling book to help ensure that parents at all economic levels know how to boost their child's achievement. Enjoy our conversation and think about Dana's advice the next time you talk with your kids. Well, Dana, welcome to Big Brains.
Thank you so much for having me.
Absolutely. It's wonderful to have you here. Now, you are a pediatric surgeon by training. Is that right?
Yes, I am a pediatric cochlear implant surgeon.
Tell me, why don't we start with what a cochlear implant is? Because I think that's key to this whole story.
It is. So a cochlear implant is an amazing piece of technology that allows a child born deaf the ability to hear, to talk, and most importantly, meld into this world both educationally and socially.
And so, as you have been doing cochlear implants for how many years at this stage?
You know, I started the cochlear implant program here at the University of Chicago over at Comer probably about 11, 12 years ago.
And so you have been doing the cochlear implants for a number of years, but you noticed something. What was that?
So started the implant program, very excited, started implanting children from the south side of Chicago, across the country, and started noticing huge differences in outcomes of my patients who all looked like they had the same potentials for learning how to talk and learn.
And what age were most of these kids, if there is an average age of kids coming in for the implants for you?
So traditionally you want to implant as early as possible. Less than a year is optimal.
Okay.
Back then it was, it's a range between 0 and 2+ So started implanting these cute little kiddos and started noticing huge differences in outcomes after implantation. Some were learning how to talk on par with their hearing peers, while others would barely be able to communicate.
And that led you to start asking a bunch of questions. Is that right?
Yes. So I always say, I realized that the cochlear implant came with a very large asterisk. And what was that asterisk? It's that the cochlear implant would allow sound to go to a child's brain, or the quote unquote hearing. But something else was needed to make those sounds have meaning. And it was that sort of realization that really started me on this journey that I always say, from surgeon to social scientist. I always say that if I wasn't here at the University of Chicago, and I know it sounds like I'm plugging the UFC, I'm not sure if this would have ever happened. They're, scientists from all different domains, from medicine to psychology to economics, really helped sort of fuel my understanding of what was going on.
Okay.
And one of the first things that I did, and you're going to laugh, is I actually audited a class in child development.
No kidding.
Yes. And that aha moment was learning about this study by Hart and Risley, which basically showed that some children, especially children born into poverty, heard 30 million fewer words than their more affluent peers
By what age?
by the end of the age of 3. But what's really important, because people get sort of stuck on this 30 million words
Right.
because it's so impressive. And it was the aha
This
moment
is
for me.
an old study.
It's
right?
a very old study, and it's really just the first sentence in a really robust literature. It is just the beginning. And if that was the end, it would be the end. But it's since then built upon by many researchers, going deeper and in more complex ways. Actually, here at the U of C, people like Jane Ellen Huttenlocher and Susan Levine and Susan Golden-Meadow and all of these amazing scientists have really shown the differences in early language environments, differences in early interaction are critical for children's, not just vocabulary development, but educational trajectories. And what's very interesting, though, is that while that was the beginning, it's really been the intersection of this with emerging neurosciences that have really brought clarity as to what we're seeing and why it is.
So from the earliest of ages, how much parents or other in their lives were interacting with them was making a difference even before they could talk.
Exactly.
Okay.
And what's fascinating is that as I learned what I was seeing in my patient population and the fact that it had less to do with their hearing loss than the world in which they were born, really took me to the next level of realizing that what I was seeing in my patient population was really just mirroring what was going on in the larger population at large. And what we talk about in terms of the educational achievement gap or opportunity gap really take their roots in the earliest language environments of children in the first 3 years of life.
There's a couple of gaps. There's a word gap and an achievement gap. Word gap leads to an achievement gap. Is that right?
Yeah, so I always say I am really not a huge fan of the term word gap,
Okay.
even though everybody associates me with it. What people talk about in terms of a word gap, it's really a metaphor for the power of early language environments in the first 3 years of life for building a child's brain. And what is the achievement or opportunity gap? That's the persistent educational differences that we see in this country, often along socioeconomic lines. So this quote unquote word gap really is one of the root causes of the educational achievement gap.
If you could define and say, well, here's the problem is pretty well articulated. What does that mean? And what do you do about that?
For me, this allowed me to see families and the inherent power in families in a totally different way. All of the parents of my patients love their children, wanted their children to be successful and happy. What it allowed me to see is this untapped power in families. Because many, just because you love your kid doesn't mean you know the brain science. I don't know about you, but when I had my first child, I had no idea the importance of talking and interacting.
Right.
And so this really allowed me to see, well, if I want to give each of my patients the same chances for succeeding after implantation, or if I want every child in this country to have the same opportunities for reaching their own potential, one of the keys was really empowering parents from all different backgrounds with both the knowledge, skills, and strategies best to optimize their children's brain development.
If the amount of time parents or others are talking to their kids up until age 3 of the brain's development is just an absolutely crucial period. And if that foundation is not put into place, it really could affect them for the rest of their lives.
I always want to say, look, it's never too late, but it is the difference of remediation versus prevention, trying to fix an issue versus preventing it in the first place. And that is really what I think in this country, hopefully we're heading towards, is really understanding that education and learning don't start on the first day of pre-K.
Right.
They start on the first day of life. And that if we're going to move the needle, we need to truly partner with those whose science have clearly shown are the key brain builders of children, parents and caregivers, in starting this optimal foundational brain development from day one.
And the solution that you kind of get into, you kind of summarize it in something you call the 3 T's. Is that right?
So the 3 T's are at the individual level, what needs to happen between adult and child to optimally stimulate the child. And what are the 3 T's? Tune in, talk more, take turns.
Okay, let's take each one of those.
All
Let's
right.
tune in.
Tuning in is really tuning into your child, following your child's lead, using child-directed speech, which is that sing-songy speech. Talk more
And
is
this is at the earliest ages of their,
This is from
Being
day one.
day one.
This is from day one. Actually, your baby can even hear you in utero. So talk more is just as it sounds, using rich vocabulary, talking about the past, the future, and the present. And then take turns. Take turns is really having a conversation with your baby from day one. It's not taking turns like sharing. And let me tell you, so these 3 T's are sort of the behavioral measuring stick that parents can use when they interact with their child. And, whether they're changing their child's diaper or, taking the Metra, it's an opportunity to enrich their environment. So the 3 T's are the foundation of all the programs that we develop. We basically develop programs to work with families and caregivers, taking what I like to call a public health approach to early learning. We meet parents on maternity wards on day 1 when their baby's born and getting the hearing test. We have programs that work through the pediatrician's offices in the first 6 months of life. We work with families at home in group settings, and we have these different interventions meeting families where they are.
Capitalism is the engine of prosperity.
Actually, it sows the seeds of its own demise.
Could both be right? I'm Kate Waldock from Georgia.
It's where to go to a bar.
Subscribe to Capitalism.
30 million words. Your center, TMW, stands for 30 million words. But there certainly is, when first got going on this, it was.
What isn't?
We're going to share this sort of irreverent banter you'd hear between economists at a bar.
That is, if economists were to go to a bar.
Subscribe to Capitalism. You can find us wherever you get your podcasts.
So Dana, when you first got going on this, it was that this number of 30 million words really stood out. I think that it's what captured your imagination from the beginning. Can you talk about the 30 million words? Your center, TMW, stands for 30 million words, but there certainly is some question of, is it 4 million or 30 million? Where does this millions of words thing play into this?
It was that number and that study which really first sort of crystallized my understanding. As I said, if it ended there and it didn't go, and all the robust science that followed hadn't occurred, we wouldn't be at this point. The initial Hart and Risley study recently has undergone the social science replication issues, and they say, well, maybe it's a 4 million word gap. Frankly, I don't care if it's 30 million, I don't care if it's 4 million. It's really the first sentence in what is, without a doubt, a robust literature connecting early language and interaction to children's foundational brain development. It's a metaphor for the power of parents and their talk and interaction to build a child's brain. So the TMW Center for Early Learning and Public Health is really an outcome of a decade of work. It's a center that's a joint venture between the Biological Science Division and the Social Sciences. I started it with John List, the behavioral economist, and it's really based on the science that we've talked about, that if we want to really move the needle on educational disparities in this country or around the world, we need to be starting earlier and using science to inform all that we do so that every child can have the opportunity of reaching their
So
potentials.
what are the goals? Is this your major outreach engine at this point? Is this center?
So the center is not just an outreach engine, it's an engine for science. Because we know the underlying science behind disparities doesn't mean that we know exactly how to approach them and allow all parents to enrich their children's language environments in the best possible ways. And so it is a center with the goal, with the overall larger goal of really a population level shift, where all parents and caregivers in this country understand the power of their language and the brain science so that they can optimize their children's early brain development.
At some point, there's likely to be a meaningful announcement coming up. And it sounds like it could end up having a pretty big impact on the work that you're doing. Can you talk about that a little bit?
We are about to announce our formal partnership for our community-wide demonstration project. As I mentioned before, we have developed this public health model for early learning. We've studied it in the small scale. Next, we're actually going to be partnering with West Palm Beach and the Children's Services Council for embedding this suite of interventions starting at day one until the age of 3, with the hopes of reaching
That's a really big deal, isn't it?
it's a very big deal. And let me tell you, there's much learning to be done. And it is going to be the result of tremendous partnerships, rigor, and sweat, and probably a few tears.
And when does that kick off?
We're probably going to be spending the next 6 months getting everything ready. And sometime in 2019, we're going to go live. This is a 5-year partnership where we're going to be embedding sequentially our interventions into different systems. So we're not starting new hospitals, we're embedding it into all the hospitals. We're not starting new pediatricians' offices, we're embedding it into there. And so the idea is to embed the suite of interventions so that the moment a child is born, they and their parents will be part of this educational continuum from 0 to 3.
The question that you're beginning to study is, how do you get the benefits of this at scale? Because then the question, of course, will turn into, if we have places to choose of where to invest, the ability to say it makes more sense to invest in this younger period ought to have exponential benefits of actually educating at different stages.
And that is why I feel so strongly that science needs to be at the basis of social change. We have had an outpouring of people saying, look, can we take TMW here and there and everywhere? We've sort of approached this in a very deliberate way, because what we want to do is take these suite of interventions and figure out, can you really link them? Can you really scale them up in a community partnership? What works and what doesn't work? And ultimately, what do you need to do to have a population level impact?
Is it a fair question to ask, if you could speculate what you would see as the broader societal benefits? What do you think those might be?
Our hope on the individual level is improved school readiness, in educational trajectories, and better long-term human capital development, as the economists like to say. So really understanding that the investment in each child is really the building block for the future of our country is so critical. When you think about it societally, 65% of all children of color are born into poor homes. And when we understand the impacts of educational disparities on human development, we need to understand this is not just about the individual child, it's about the future of our country.
And the cost for not making those choices.
And the cost for not making those. Obviously, James Heckman, the Nobel laureate, is very well known in the education circles and more broadly for talking about return on investment of early childhood. And yes, there's no doubt there is a significant positive financial benefit for investing earlier than later. That's great. But even more, there is a huge return on investment for the strength and the robustness of our country.
If you're listening to Big Brains, there's a good chance you consider yourself a lifelong learner. However, you may not know about the University of Chicago's Graham School and its focus on continuing liberal and professional degrees. Visit graham.uchicago.edu. So if you could wave the wand and say, what I would like to see in place, and for this reason, and here's the output or the impact I'd expect, how would you articulate that?
If you gave me a magic wand, there are many things I would do.
Okay.
But in terms of what we're actually doing, I would love that we understood that learning doesn't start on the first day of school, but the first day of life, and that the educational continuum in this country begins on day one and puts those who are clearly the brain builders of our country, parents and caregivers, at the center of it. At the same time, that doesn't happen in a vacuum. We need to also understand the different things that need to happen to support families and caregivers in optimizing children's outcomes. Paid parental leave, high quality early child care opportunities, better early mental health. I mean, there are many different things, impacts on toxic stress. So there are many things that I would do to sort of change the 0 to five landscape, but I think more intentionally putting parents and caregivers at the center will be really important.
So you're a mom, you have 3 kids, so you're past the age of impacting you with the youngest phase. But did these insights for you change at all the way that you were interacting or raising your own kids?
You know, I often joke, I wish I had known this information when I was having my children. Thankfully, my kids have turned out okay, despite me. But, you know, I think that's the whole point. I mean, I still remember coming home the first day with my daughter, Geneviève, and, you know, thinking about putting her in her car seat, in her crib, you know, back to sleep. And I really had no understanding of what it was or the importance of thinking about helping develop her brain. And that's sort of the gap, right? When you go into your pediatrician, you learn, you know, about nutrition, feeding. There's really much less discussion about this important information. I mean, hopefully it's shifting. And so, yes, I mean, just because I was a surgeon, I didn't know this stuff. Obviously, you know, when I have grandchildren, it'll be a little bit different, but it has changed how I look at children. What's really amazing, and this is the coolest part, is when I look at little kids, you know, little infants, I don't just see a cute sort of responsive baby. You can almost see their brain connections happening in front of your eyes. And I think that if we, you know, if you could actively see brain growth, I think we'd all act very differently and invest very differently societally. But maybe understanding the science will give us all sort of an appreciation for these complex little beings who are doing a lot of development.
So if we were going to sit down and you're going to give advice to expecting parents, parents of newborns, parents of kids under age 3, and they're saying, oh my gosh, what am I supposed to do with all of this? What would you tell them?
Number one, to understand that babies aren't born smart, they're made smart, and they're made smart by parents talking and interacting with them. That you are your child's first and most important brain builder. And how do you put these strategies into practice? We share the 3 T's. Now, it sounds like it's just about information transfer. It's obviously much more complex than that. As we know, behavior change is hard. Otherwise, we'd all be exercising and eating right. But really, it's going to be the science and the feedback from that that'll allow us to understand what strategies work and what don't work. And we're already finding just fascinating things from the research that we're doing here in Chicago. I think the take-home message is there should be great joy in this. This is not supposed to be a task. It's not supposed to be exhausting, although let's face it, parenting can be. But it should be joyful and with the added benefit that you're changing your child's trajectory.
And now that you have the education to do it with a not terribly complicated ask, something it's just a matter of knowing that actually makes a difference and important, you can make a huge difference.
Yeah.
Okay, you've been a wonderful guest. Look forward to see all the developments continue.
Thank you. Thank you.
Big Brains is a production of the UChicago Podcast Network.
All right. So hopefully that was interesting to you all. I think, does anybody want to share a key takeaway that you had from listening to that? We know now about the 3 T's. That's what needs to happen between a young child and an adult, or maybe a parent or a caregiver, an adult that's involved in their lives, in order to optimize brain development. And we know that there are less opportunities for that and the lower tendency for that to happen in children where there is socioeconomic gaps and even single parent homes and other types of stressors in the environment. Because remember, it's not just genetics, it's the environment and the experiences that impact brain development. Oh yes, Bree's got a good, I was going to say, I'm going to post the link to the website that's about 30 million words. And Bree is recommending for us the book, 30 Million Words. Very, very interesting. And really very relevant to any of our work in pediatrics or just even human development. So Okay, so thank you for your attention to that. And let me get back to sharing my screen so we can forge on. Here we go. All right, so we're moving into past early childhood development, and then there's more and more synaptic growth and pruning that happens in elementary school and into middle school, and then we hit adolescence, which besides that 0 to 3, or some say 0 to 5 age range, adolescence is the next time when there's just such a massively incredibly massive amount going on in brain development. So let's start by talking about what adolescence is. It's really, we talk about that word like it's obvious what it is, but it's really a relatively new concept, even to recognize that as a specific part of human development, a specific phase. We used to just consider it part of childhood. So we had childhood and adulthood and maybe older adulthood. We didn't have adolescence as its own phase. But more recently, in the past 20-ish years, maybe 30, we have had that. So we say it's a fairly or relatively new concept. And it also is cultural in the way we think about it. So in our culture, we think of adolescence as kind of the connector or the transition period between childhood and adulthood. We see that now it's being understood as starting in that kind of middle school age, roughly 11 to 14, pre-teen-ish to very early teens, and then moving into the late teens, and even sometimes we consider it into the very early 20s. And that it can be individual as to when those behavioral and cognitive and other developmental milestones are met in some people. Social emotional milestones are big in that time. Lots of cognitive milestones. And we know now that the frontal lobe, remember where that executive function really largely comes from, is not typically done being developed until around 19 or 20 for females and around 20 or 22 for males, typically. So the early end of adolescence is marked by puberty, and that's why there's that age range. And we do say that it is much more socialized. It's not something that we can look at somebody and know for sure where they are exactly in development or even within adolescence. We can probably look at them and think, yeah, they're adolescent. I used to work with a nurse, and she had 2 teenage sons, and she used to always tell people that she spent most of her time with inappropriate adolescent males. And she would come to work with all these really hilarious stories of things that they did, just all these shenanigans and lots of, trying to figure out their boundaries and impulse control issues and just goofy things that they did. But that's kind of what I think of when I think of like capital A adolescence, that big transition. And it's of course not overnight. It doesn't happen like January 1st this certain year and it's over December 31st this other year. It's much more gradual, sliding in and then sliding out of it. But it is that transition, and it's important. And there's a lot to be said for working with adolescents, that age group. I think it's fascinating really to see and to think about all that's going on in their brains and in their bodies as a whole. They really are very much trying to be adults and thinking about independent choices and establishing themselves as independent entities separate from their parents and other adults. They connect much more to other people their age than they do oftentimes to their own family members, and certainly to adults and older adults. So we can't really define adolescence by age. We can't say it's always 13 to 19. There's that range that we see. And that's really because the onset of adolescence is marked by the onset of puberty. And that does occur at different ages for each individual. We have a rough idea of when that happens. Puberty being defined as when somebody has the capability to reproduce. That's sort of our societal definition of that. So something I want you to think about is what we know about the teenage brain or adolescent brain development that we didn't know even one generation ago. So even roughly 20 years ago, what's something we didn't realize about the adolescent brain? Do you all have any thoughts on that? You might have some insight from your own experiences because you're kind of at the cusp of that. I'll tell you a big one, and I actually learned this in a class I took when I was getting my master's about adult learning, and because adolescents, can go up into college age, even though we don't tend to think of it like that, but it really technically does. When I was getting a degree in adult education, which is what my master's is in, we began by studying adolescence and brain development and how that connects to other developmental phases in life. And one big thing that I learned, and I remember reading an article about this, and I'll post that for you guys to read if you're interested, is how the development of the amygdala really impacts decisions and functioning of the frontal lobe. And so, in other words, when someone is under stress, whether it's real, whether they're really in danger, or if they just perceive themselves as being potentially in danger, their amygdala, that fear system within their limbic system, is in overdrive, and it very much impacts their frontal lobe and even their hippocampus. So in other words, if you are in a state of sort of mental or emotional crisis and your amygdala is really working overtime, it's very hard to learn. And that really impacted a lot of what I think of in designing things for my teaching, that that relates back to what I said in the first or second time we met for foundations, that just like in OT, we're always striving to find the just right challenge for our clients, but it's the same in teaching and learning too. If somebody is very, very stressed out, even because of something environmentally like sleep deprivation or nervous about something, and your amygdala is really in the command center at that point, and it's really hard to learn and even retrieve things so that you can do as well as you could otherwise. So something to think about in how that might relate to patients, clients, and even family members of clients that you may deal with in the future. If somebody is just consumed with, really focusing on their emotions and their fear and the trauma that they have gone through or are going through, it's harder for them to listen and pay attention and think straight and think rationally. And so you may need to repeat yourself. You may need to do techniques like ask them to explain it back to you, just to check in and make sure they're really getting it when they're in a state of high stress or anxiety. So that's something about especially the adolescent brain, that's particularly of note. And that goes into adulthood as well, but we see that happen frequently in adolescence just because there's so much going on socially with them, and they're kind of developing their own independent identity. Something to think about. All right, so that it concludes our talk today. I'm going to post a couple things that I referenced in under the session 8 folder. And so our next class session in this course will be session 8, and it is asynchronous. So some of it's open now. The quiz that goes along with it, quiz 3, will open at 8 o'clock tomorrow morning, and then you'll have through Sunday at midnight to complete that. So it's on Team Up, but just as a reminder, make sure you do that because there is a quiz attached to it, and just to keep up with the material that we are going through. There's some activities and things like that that you're going to need to do when you are in the midst of that asynchronous unit. Any questions for me or anything anybody else wants to share before we conclude? Nope. Okay. Well, thank you for your attention, and I will see you guys next week. Have a good weekend.